Hi guys, so we're gonna do this lesson today. You're gonna listen to this video and then follow along to understand what is a logarithmic function. So we have talked about inverses before. We've talked about the inverse of quadratic, we've talked about the inverse of linear, we've talked about the inverse of other functions. And we basically said that to inverse, you're gonna basically, if you have a point, it's a reflection. If you look at your point, it's a reflection on the line y equals x. So you see the line right here, which is y equals x. So your original function is the blue one, right? Your reflected function, or the inverse function, sorry, not the reflected, is the one that's reflected along the y equals x. And the reason is because, as we know, the x and the y, they switch, right? So your original point, which is x and y, for the inverse function will be reversed. So the y becomes the x and the x becomes the y. So that is true for all types of functions. So as you guys can see for this one, in this case, we have an exponential function, and we need to sketch the inverse of these exponential. So in order for us to switch, basically the easiest thing to do is to find some clear points, right? So these clear points that you guys can see here. And then inverse, or sorry, switch their x and y. So this point here is negative 1.5. This point here is 0, 1. This point here is 1, 2, and this point here is 2, 4. Okay. So what we can do, we can find the inverse by switching the x and the y. So that's going to be 0.5, negative 1. 0, 1 becomes 1, 0. 1, 2 becomes 2, 1. 2, 4 becomes 4, 2. So we see that if I pick like smaller numbers here, so negative 2.25, right? So so that's 0.25, negative 2. So you'll see that the graph is gonna come down. This one had a horizontal asymptote. So the original function, the exponential function, had a horizontal asymptote at y equals 0. Guess what? The inverse of this will have vertical asymptote at x equals 0, right? Because remember, the x and the y switches, right? So we see that. And then our sketch is going to look more like such. And this is basically a reflection on y equals x. Let me see if I can do that. There you go. So this right here is y equals x. Right, and then the red exponential is the original function. The blue is the reciprocal of that. Or I keep saying reciprocal, it's the inverse. It's not the reciprocal, they're not the same thing. Right, so that's another one. That's another exponential. So this is an increasing and exponential. You see that the inverse is still increasing. All right, this is also increasing. So what we see here, we see a plateau or a horizontal asymptote at y equals 3. Right? So we're gonna expect a vertical asymptote at x equals 3 for the reciprocal, for the inverse. your original points. So let's look at these points here. We have 0, 2, something more clear. This is about -2, -3, or -3.5. I think it is more like it. It's more like here. I always like the 0. So that's 0, -1.25, I guess. So we have, so let's write this down the other way around. I am thinking ahead. And this is -2, -3.5. And this is 0, 2. So the inverse, so we're going to have 2, 0. We're going to have -3.5, -2. And let's look at this one. So it's going to be 0, -1.25. So it's about here. So you're going to see that we're going to have something that looks like this. All right. Now, we have looked at how to graph the inverse of exponential. Now we are going to look at the equation. Okay, so the original equation here we had was y equals 2 to the power of x. So that is the original. Now the question is, how do you find the inverse? Okay, we know that to find the inverse, first thing we need to do is we need to change the x and the y. So interchange the x and the y. So we have x equals 2 to the power of y. Now, here's the next step. We usually, how do we isolate for the y, right? Because remember that after you do that, you need to isolate for the y. So the next step is, so first step is interchange x and y. And second step is isolate for y. Okay. Now to isolate for y, because y is in the exponent, I need to do the log. Okay, so I need to do the log, and basically log is a base 10. Okay, log is usually a base 10. But in this case, and we don't usually write this one, like the square root, like the x, right, where we don't write there's specific things like square root, we don't write that too, right? X, we don't usually write x to the power of 1. Same with log. It has a base 10 because it's the opposite operation of 10 to the power. Okay, so whenever I have 10 to the power of x, to get rid of that, I do log. All right, log base 10, that will get rid of the 10, and then you'll be left with just x. Okay, so the idea is log as is a base 10. Okay, in order for me to cancel any base, I need to make a log of that base. So the inverse of this, remember I'm isolating for y, right? So the inverse so that's very, very important. So it's switch to log base 2 x equals y. Okay, so you see that the base here becomes the base of the log, and your output becomes your input, and your input becomes your output. Okay, so we'll do more examples of this, but the understanding is that you do log base 2 because that's the base of the output equals the input. Okay, which now it becomes the input becomes the output and vice versa. So here's another example. Okay, so we have y equals negative 0.4 to the power of x plus 3. So that is your original. Okay, to find the inverse, you have to isolate. Okay, we have to isolate. So the first thing, let's interchange the x and the y. So x equals negative 0.4 to the power of y plus 3. Right? And as we know, we need to isolate for that exponent of y. We have to do reverse BEDMAS. So we bring the 3 over, so that's x minus 3 equals negative 0.4 to the power of y. Then we're going to have to divide by negative 1. Now to divide by negative 1, we have, that will be like negative x plus 3 equals to 0.4 to the power of y. Now here is where you need to be careful, because that's when I need to get rid of my to isolate for my exponent. And to isolate for the exponent, you have to do log of that base of whatever my answer is equals to the exponent. All right. So so the inverse equations you found above don't have the output isolated, and hence cannot be written in function notation. This is one of the reasons that logarithm were invented. So you see how that power of y, right? You can't isolate for it, so you can't write it in function notation. So the formula says, okay, so we have k equals L to the power of m, right? So this is my exponential. This is my exponential. Okay. This right here is the output of exponential. This is my answer when I do whatever to the power of whatever. This is the base of exponential. And this right here is the output. So this is basically your, why am I making a lot of mistakes here? This is your input. This is your x of exponential. Okay. This is your y of the exponential. This is the base of the exponential. So to write it in logarithmic form, what we have to do, so it will become log base L, right? Because that's the base of the exponential, becomes the base of the logarithm of k equals to m. Okay, so this is where the base of the logarithm, this is the base of the logarithm. As you can see, it was the base of the exponential. This used to be the output exponential of exponential, became the input of log, and this became the output of log. Right? So you're gonna change, the base becomes the base of the log, the input becomes the output becomes the input. So let's look at some practicing, okay? So I'm going from logarithmic to exponential. So the base of my log becomes the base of my exponential, so that becomes P. My output becomes my input, so becomes my exponent, equals to Q. Okay, now going from exponential to logarithmic, the base become the base of the log of the answer equals the exponent. Okay, think about this for a second. How would you write that as an exponential form? So you should be saying 4, which is my base, to the power of half equals to 2. Okay, so that's a base to the power of the answer, right, equals the whatever the log that you were taking, which should make sense, right? 4 to the power of half, that's the square root of 4. Square root of 4 is 2. Okay, now let's think of this as a logarithmic. So what would be my base? So I should have log base of 1/5 of 1 over 25, and that should equal to 2. Right? You should do a few practice questions, and you'll be okay with it. So what meaning does log base a of x have? So a logarithm is an exponent. It's the inverse of an exponent. So remember that log base a x equals y is the same as a to the power of y equals to x. All right, so let's try to evaluate here. Now, if we are doing regular log, so just log, no base, your calculator will have a button for that. Now, some calculators do have the log where you can put the base, but some don't. So we're gonna have to learn how to do that, okay? So to do that, which anyway, you are gonna have to do it. So to do that, we need to write basically the same base as the base of your log, okay? Because what happened is that if you have, let's say, log, I'm just going to write something here. So if you have log base a of a, right, the log base a and the a cancel each other, and then you'll be left only with your exponent, okay? So you want to make sure that whatever your base is and the base of your exponent are the same, so you can cancel the log and the base. All right, so we have log base, what is that? Sorry, I didn't mean to start from here. I meant to start from here, so that is 1 million, okay? So log base 1 million. So that is, I can write this 1 million as a base 10, because remember that the log has a base 10. So that's 10 to the power of 6. 10 to the power of 6 is a million. When I do this, right, what happened is this and this, they cancel each other, okay? And then you'll be left with just 6, okay? If you do on the calculator, like log base 10, 10, it gives you 1, okay? If you do log, if you have a calculator and then you do log base 2, 2, it gives you 1. any log of the same base of that number, it's going to give you 1, okay? And then we're going to learn later on with logarithmic law. And this is, I think I want to mention it right here. So let's say if we have log base 10 to the power of 6, okay? Why does this equal to 6? I just want to explain that to you. So what happened here is that the logarithmic law says, whenever you do the log of the base, right, of 10 to the power of 6, what happened is that exponent come down and becomes a multiplication. That's why we love log, because log makes your exponent multiplication, okay? So that's the same thing as writing 6 log base 10 of 10. Log base 10 of 10 is 1, and we've already discussed that. And 1 times 6 is 6. So that's why we get an answer of 6. But we don't have to show all this work. We know that anytime we write the log of whatever the base is, and then we write the exponent as that same base, they cancel each other, and then we'll only be left with the 6 because of what just happened right here. Okay, I'm going to leave this here on the side just so you can see it. And then we're going to talk more about exponent laws later. So let's look at this one. Okay, remember that we have to make it base 2 because my base here is 2. So we have log base 2. 16 is 2 to the power of 4, right? 2 to the power of 4 is 16. So what happened here is the log base 2 and the 2, they cancel each other, and you'll be left with just 4. Okay. This is, if you recall, I gave you a question in the previous unit, I think, and we were kind of discussing that in the previous unit, I think in the previous lesson, yesterday or Wednesday, or like 1. How can I do that? How can I have that the same base as 5? And I think it was Caitlin standing at the back and said, 1 is 5 to the power of 0, right? So anything, when you see 1, think about what the base is and then put that base and then to the power of 0. Okay, so your answer for this is 0. So any log base of any, like the log of any base of 1 is 0. Okay. Now let's look at this. This is a rational number, okay? And we know that when we have a rational number, we have to think about negative exponents. So what is 1 over 64? So I think that is 2 to the power of 6, right? So if I do 1 over 2 to the power of 6. Now, remember that I need to have the same base. So instead of writing it like this, I am going to flip, right? So flip this, make it up. I'm going to put it in the numerator and make the exponent negative. So that is the same thing as 2 to the power of negative 6. And remember, I need to have the bases the same, okay? So that gives me negative 6, okay? If you have a calculator that does this, you can check your work. Now, you still have to show me the steps, but you can check your work, and you should have a calculator that have this button, okay? If you have a calculator just as log, tough luck, you can't do it. You have to actually calculate it that way. I'll show you another formula, but you also need to figure it out that way for now, okay? All right, let's try this one here. So this one here, I have the 7th root of 9. I know that the 7th root of 9, I can write that the 7th root of 3 squared, right? I want that base 3. I'm thinking of 3, and then I wrote it there. Now we know that the seventh root can be written as, and rational exponent, so that's 2/7. And now my log base 3 and my 3, they cancel each other, so that equals to 2/7. All right. I want you to think about this for a bit and try it, and remind me to check your answer on Monday. Okay, so I'm not going to do this one. I want you to think about it. I want you to try it and remind me to show you the answer on Monday, or to check your answer. Okay. So this is basically evaluating, so finding what that value is. And as you can see, we could use a calculator for this, but again, not all calculators can do log of a different base other than 10. So let's look at how to find the inverse. So remember that we're going to use the formulas that we have seen so far today. That's exchanging between log and exponential, okay, to isolate for the, to find the inverse. So first thing, you're going to switch your x and your y. So you switch the x and the y. Okay. Then you're going to try to isolate. Remember that we try to get rid of everything until we get to the log and whatever is in the parentheses around it or inside of it. So the first thing we're going to do, we're going to get rid of that 2 by dividing by 2. So we have x/2 log base 3 y minus 1. Okay. Now we're going to have to change from logarithmic to exponential. Okay. Remember that the base of my log becomes the base of my exponential. My output becomes my input, and I have y minus 1 left. Okay, so the way I think about it when I have it written in this format, I take this base and I raise it to the power of this and equal to this. This is how I visually see it. So now we have that. We're going to have to isolate for y completely. So we'll end up with 3 to the power of x/2 plus 1 equals to y. So this is the inverse of the function above. Okay. So I'll do A and B, and I'll give you some time, and then I will check C and D when I get to school on Monday. Okay, so for this one, we have we need to isolate. So first thing, we're going to have to exchange the x and the y, or interchange them. We're going to isolate for that y. So in this case, I'm going to cross multiply. I'm going to bring the 3 over. It's going to become a multiplication. So 3x equals 4 to the power of y minus 1. I still have that minus 1 that I want to get rid of. So I bring it over as a plus 1. Now I only have 4 to the power of y, so I can use my log formula, I guess, right? So basically we write log base 4 of whatever the answer is. So that's 3x plus 1 equals to y. Okay. If you guys remember, I told you there is a reason for it. I'll tell you, I'm going to show you why now this would work. So I'm just going to bring this over here. So I have 3x plus 1 equals to 4 to the power of y. So anytime you want to isolate for an exponent, we say we take the log of both sides. Okay, so the log of both sides, that means I have to take the log of 3x plus 1 equals to the log of 4 to the power of y. We said that if I take that y, if that exponent y will come down and becomes a multiplication. So I'll have log base. So 3x plus 1, I missed an x here, equals to y log of 4. Okay, so far I haven't used the formulas that except like when you do the log, you bring the exponent down. Now I'm gonna divide by log 4. Okay, now you look at these two and you say, how are they the same? They're not the same. Well, they're kind of the same. And this is where the other formula that I told you will come in. So whenever you're dividing by a log, that right here, you can rewrite this as a log base 4 of 3x plus 1, okay? Because there is a formula that says log m over log n. We're going to talk about this more, okay? It says log m over log n is the same thing as log base n of m, okay? So these are the same thing, and that's why I can, so this is another formula. We're going to talk about, these are exponent laws. We're going to talk about them on Monday, but there is a log base 4 of 3x plus 1 equals to y, okay, using this formula. Okay, so there is a reasoning for it. We have learned the shortcut, and the shortcut is you do the log of the base, right, of the output equals to the input. Okay, that's the formula for it. So what I want you guys to do, I want you to take some time to do C and D, and then I'm going to post some worksheets that I need you guys to work on. Okay, try to get them all done as much as possible. Okay, you can work in groups. You can work on the whiteboard if you guys want, but as long as you get them done.